to present to 3 people. And I'm going to do this quick because you all want to go home. So, opexpire, what is it? Anti-CheckLockTimeVerify. It does basically the opposite of it, which is, if you remember CheckLockTimeVerify, it's associated in lock time. You prevent a transaction or an output from basically being spendable until a time period. Opexpire, as the name suggests, prevents it from being spendable or mineable after a time period. And concretely, that means we actually need 2 things in it to make a usable thing. One is we need an opexpire opcode, but then we also need some kind of an expire height field. Unfortunately, we have the taproot annex, so this is actually doable in taproot. And being a new thing, is probably fine to just not allow it in old stuff. And that's simple enough. Well, why would you use it? Well, there's a whole bunch of stuff like auction bids, time-limited delegation, provably unspent. Because lock time just doesn't have the bits to do it. And also, sometimes you're going to want to do both. So, lock time has a meaning already. There's no easy way to say, well, lock time, but interpret it differently or something. I did propose maybe you could squeeze into version bits or something, but just doing it as taproot annex field seems pretty reasonable. Yeah, it's probably all right. And and I got to point out too, if you somehow have a transaction which doesn't have signatures on this stuff, you can always just change the field anyway. Yeah. So it has to be in something that's signed. But yeah, auction bids, time of provably unspendable outputs is an interesting one because we do have op return right now, but sometimes you might want an output that disappears from the UTXO set after a period of time. Now, actually doing this is a little tricky because then you got to pick, well, what opcode is it going to be? Are you going to do it repurposing a taproot op success or something? But, it's something that can be debated later. I've been told, although I haven't bothered thinking in much detail how the heck vaults would go use this. I'm sure people who care about vaults can figure that out. And the one that I came up with, the whole reason I came up with opcode at all, or at least proposed it and wrote it up, was the transaction cycling attack. And I think this one's interesting because it kind of it speaks to something where I think people have been often maybe, not so much misunderstanding, but just kind of not thinking through the implications, which is, HTLCs, right? They're pre-image or refund after timeout. The problem is that is a programmer's OR. It is not an exclusive OR. And, I could give 20-minute talk on transaction cycling attack. Actually, no, I couldn't because I have to remind myself how the hell does it actually work. But, the basic issue with that is the pre-image part of that can happen later than you'd expect. So if you add an opexpire to that, well, the pre-image thing can't happen after you wanted it to. Thus, that solves the transaction cycling attack. Because the attacker, their choices are really to either collect the money when they give the other guy the possibility to collect the money too, or not get the money. Solves it quite nicely. So the other question is, well, why haven't we done this before? And, the whole idea of making transactions in any form that become unmineable in the future really comes down to reorg risk. Because we have this idea that if a bunch of blocks get reorged in some massive technical failure, we want all the transactions in those blocks to eventually be able to get into the chain. And lock time has this property because we assume that reorgs aren't somehow going to make the chain shorter. They can actually, technically speaking, but that sort of reorg situation is, I think, kind of so rare and so unlikely we can ignore it. So, and lock time has this problem, but expiry definitely does, because you could wind up with some empty blocks and then maybe it's just impossible to get in. Well, what's the solution? Well, you got to ask, well, why is reorg risk a problem? I mean, we don't so much care about the transactions getting screwed up. We care about the transactions after getting screwed up. And we already have this issue with Coinbases because, if you spend a Coinbase output, it gets reorged out, it's invalid. And Coinbases are unspendable for, I think it's 100 blocks, 101 blocks. There was an off by one error in this somewhere. But, they're unspendable for a while. So you could imagine fixing this reorg risk by making n expiry height using transactions, the outputs of them unspendable for, say, 100 blocks, or maybe 10 blocks is enough. that can be bike shedded over. But I argue, certainly if it's no worse than Coinbase's, it's acceptable. Might not be as useful, but it is acceptable.
I'm sorry. Where does opexpire come into that? I think
Well, because opexpire, to make it useful, what you're really saying is that a transaction spending an opexpire cannot be mined after a point in time. All right, so like CheckLockTimeVerify, opexpire, the most likely implementation, would check an expiry height field, and an expiry height would say the transaction containing this cannot be mined at some point in the future. That's the equivalent of saying, this output is expired, or at least this branch of the output script is expired and cannot be spent that way. And, like I say, I think it's similar logic to CheckLockTimeVerify there. And the other bit of why haven't we done this before is, well, this makes mempools look kind of complex, because now you have this whole class of transactions that could drop out of the mempool forcefully. This is potentially a free relay attack. You can imagine sending out a bunch of transactions with really low fees that are going to expire the next block. And the chance of the transactions actually getting mined is pretty low. So you're really getting broadcast data for free. And as I've argued in my talk yesterday, well, we already have free relay attacks, but this is a particularly free version of it with very little cost versus, low cost. But there's an easy solution to this, which is you say, well, if transactions accepted into your mempool with an expiry time, if the expiry time is reasonably close, well, you should go require higher fees. I mean, the obvious way to do is just say it's got to be a fee high enough to probably get mined in the next block. And implementing this is currently kind of hard because you can't ask the question, well, what is a fee high enough to get in the next block due to how we design mempools? But, I'm sure we'll fix that at some point. So it might make opexpire easier to implement. And finally, why did I talk about expiry heights? Why not time? Well, because time is weird. And time has all kinds of crazy, weird incentives that are possible. Because, a lot of people have this idea that Bitcoin serves as a clock. That's not really true. The definition of validating a Bitcoin block correctly requires you to have an accurate local clock. Because the part of the definition is the time field more than 2 hours into the future? Which is also a very bizarre thing to have, because, your and my clock are not going to be absolutely identical. And we kind of hand wave over this, and we really hope miners don't exploit this. Well, let's not give them more reasons to play with time. We're all better off if no one looks too hard at this weirdness in Bitcoin, and height is good enough. I can't really, any circumstance where you've got an expiry time, the reality is, at least currently, the block adjustment interval works pretty well. It's never off by more than, 10, 20%. Certainly never off by more than 10x in either way. So it's fine. Just do it by height. Simple as that. And finally, deployment. Well, I would suggest hats. That seems to be the way we deploy things. You might want to do a better job at making the hat than that. I use GIMP, and I typed opexpire with the default sans serif font. I hear there's cool things you do with little rubberized 3D things, but I'm sure we'll figure out some deployment thing. One argument here is if opexpire is actually useful, maybe the way we do deployment is by saying, hey, here's an uncontroversial thing. Let's see if we can get an uncontroversial thing in. I don't think that's the case, because opexpire has more than one use case. If all it did was fix Lightning HTLCs, I might have a point. Unfortunately, I don't, because it looks like there are other use cases. And I don't, people might oppose it based on, well, maybe you can use it for ordinal inscription auctions or something. I don't know. But it is what it is. So with that, questions? Uh-oh. Well, I'll ask him. There. You already asked one.
Do you get generalized covenants with opexpire?
God, I hope not. But I'm not going to say no. Maybe if it was in the morning, I'd say no. But, after watching all you guys talk about generalized covenants, who the fuck knows? But honestly, I'm pretty confident it doesn't do anything more than the sort of stuff I said.
Yeah.
But even then, enabling new types of auctions, I'm sure lots of people hate me for it.
How would you, for setting the fee rate, if you were going to say, hey, this op expire, this expires in the next block, would that, you said it was based off your mempool, or would you base it off of the previous last confirmation?
I mean, realistically, it's going to have to be like a local mempool.
Yeah.
And, a nuance of that too is like, this may of course be a package relay situation where the transaction itself is not enough, but there was a child one, which of course gets to a problem because I did just say Coinbase-like behavior. Yeah. So, there might be like some opt-out thing you have where maybe if it's in the same block, you're allowed. I don't know. I mean, it's a tricky whole design decision, but certainly I think in most use cases, it's good enough to just create a bunch of, transactions with different fee rates and just rely on RBF for that. Like there's no reason why one op expire couldn't be replaced by another one. I mean, of course, after all, fee rates could go up after it's accepted. Maybe it's just like any other transaction, it's still not enough to get in quickly. Yeah. So, but yeah, like that's part of the design criteria and design decisions around this. I'll also go point out, with regard to the Coinbase-like thing, there is precedent for op expire in other blockchains. And my understanding is most of them just said YOLO. Like, if reorgs happen, we'll deal with it. And, I'm not sure that that's like so unreasonable. Like, we're already leaning towards making reorgs dangerous anyway with things like ephemeral anchors where like anyone can pick them up. Yeah. So, and of course, RBF has the same issue too. Yeah. Like, RBF is heavily, heavily used. And in any reorg where miners start doing something weird, you could easily be in a situation where the wrong RBF is in. On the other hand, in situations where the reorg is some technical failure, well, there is arguments that at least it provides a possibility of getting in. Yeah. In a sort of cooperative way. So I don't know. We can bike shit that more.
So I was kind of really interested in when you said it will disappear from the UTXO set. That's really useful especially for people who are like, there's been this kind of...
Well, op expire could be used for like ephemeral anchor outputs as an example.
Yeah, sure, yeah. But also just like, there's been a lot of spam and like loading the UTXO set, and it would be kind of neat. I don't know if it would be useful, but like, it would be neat if you could opt in to having your transaction become unspendable after a while. The data would still be in the chain, but not on the UTXO set.
One nuance of this, of course, is that you do have to do it in a way where it's possible to prove that. Yeah. Right? It's got to be visible to the code that can process the UTXO set. An op return is an example. The reason why it's encoded as op return the thing is so that code can just read the script pub key directly and say, oh yeah, that's op return. Yep. So you'd have to have some standard like, well, maybe it's, some number op expire, maybe drop depending on how exactly what exactly the meaning is, and then followed by whatever else is. Of course, that conflicts with how we've defined like taproot and stuff like that, because we say taproot is this fixed script pub key, not this not an opcode. Like we done op eval or op taproot, it'd be a different discussion.
Yeah, I guess it would work if you had like one branch that was op expired, but if you had a bunch of branches that were op expired.
I mean, even if it's one branch in a very predefined way, but then it's not very useful. Because how do you add some other thing? I mean, maybe if it's only for ephemeral outputs and absolutely nothing else, maybe that's enough. But,
or like to store arbitrary data.
Well, there's that too. But, I mean, the problem is, though, if it's stored arbitrary data, well, the data, again, you get into this thing of how exactly did we encode op expire? Because script pub keys are only version 0 scripting. Yep. Right? All the taproot scripting is not part of version 0 scripting. So I can't like repurpose an op success for this. It would have to actually be a op expire verify. Yeah, you can bike shit this stuff to death. But cool. All right, we're done. Let's go home. Let's eat.